Okay, so this is 5.5 Trigonometric Equations. We are going to be using skills that we did in Chapter 4 and in 4.7 to do these, okay? So 1 through 10, I think you guys are going to do okay with. These are just using substitution to determine whether the given value is a solution of the equation. So you're going to substitute this value in for the x and see if it matches. This is a little bit blurry. I apologize. It's not the screen, it's the printout. So putting that in, we've got cosine of 2 pi over 3. Does it equal negative 1/2? Well, you're going to have to use your unit circle. And at cosine of 2 pi over 3, my value is negative 1/2. That matches. So yes, it does work. Okay. Now, looking at this second part, this is going to be a little bit more challenging because we have some general answers in addition to the concrete answers. Okay. All right. So let's start with number 13. So we've got tangent of x equals 1. Right. So tangent of x equals 1. I need to find any place on this unit circle where my tangent of that value would equal 1. Remember, tangent is the relationship of sine over cosine. So then we have to find sine and cosine that is the same. And there's two places on this circle where that happens. It happens at pi over 4, and it also happens at 5 pi over 4. Okay, so we have it at pi over 4, and we have it at 5 pi over 4. But here's the thing. This is a circle. It's periodic. So every time I go around this circle, I'm going to land on those places. So that's multiple answers. Okay, now let's take a look at tangent. Tangent is has a period of 0 to pi, right? So then I can say that it regenerates, it repeats itself every pi, so every pi cycle. All right, so if x equals pi over 4 and then plus n over, or not n over, n pi for the general form. Well, if n is 1, then that would be pi over 4 plus pi, 1 pi, which is the same as 4 pi over 4, well, that would give me 5 pi over 4. So this answer is here. These are the same. So I do all of that to say for tangent, you only need to have one answer. And it's x equals whatever that value is on the unit circle plus n pi. And that's going to be your solution for these here, for tangent and cotangent. Now, for sine and cosine, so looking at number 21, for example, we've got 4 sine theta minus 1 equals 2 tangent theta. I can't seem to get this organized. There we go. All right, so 4 sine theta minus 1 equals 2 sine theta. Remember, I'm okay if you decide to use x instead of theta. It is just representing a variable. Okay, so I want to get my sines on one side, everything else on the other. So I'm going to add 1 to both sides. And I'm going to subtract 2 sine theta from both sides. So then I've got 2 sine theta equals positive 1. I'm going to divide both sides by 2. And so now I have sine of theta equals 1/2. So I need to find places on my unit circle where my sine of that angle would give me 1/2. Okay, sine is going to be positive in the first and second quadrants. So looking here, sine is the y-coordinate. We have 1/2 here, and we have 1/2 here. So that's pi over 6 and 5 pi over 6. So pi over 6 and 5 pi over 6. But remember, sine it repeats every 2 pi. So it's going to be pi over 6 plus 2n pi and 5 pi over 6 plus 2n pi, where n is an integer, okay? Because that's going to happen every time. So for sine and cosine, you're going to have two general answers that occur within the unit circle, and then the 2n pi. Okay, the one that is the most confusing is going to be this one here. So when it says find, it involves equations with multiple angles, solve each equation on the interval of 0 to 2 pi. So that means we have to find all of them. All right, so looking at number 27, we've got the cosine of 4x equals negative root 3 over 2. Okay, so looking at this, the first thing that I want to do is take the inverse cosine of both sides. And so then I have 4x equals the inverse cosine of negative root 3 over 2. So cosine is negative in the second and third quadrants, and cosine is my x coordinate, so it's going to be 5 pi over 6, and it's also going to be 7 pi over 6. But I don't know which one, so I'm going to write down both of them right now. So I have 5 pi over 6, and I have 4x equals 7 pi over 6. But remember, that's the general form, or that's the form. But then I would need to do plus 2n pi to get all of them on the cycles, and the same with this one, so plus 2n pi. We have to do that before we solve for x, right? Now I can divide both sides by 4, or multiply both sides by 1/4. That's going to cancel and give me x equals 1/4 times 5 pi over 6 is going to be 5 pi over 24, plus 2n pi over 1/4 is going to give me n pi over 2. Okay, now in order to add fractions, they need to have a common denominator, and this is going to be, so if n equals 1, then I have 5 pi over 24 plus 1 pi over 2, which is going to be 5 pi over 24 plus 12 pi over 24. So then I would have 17 pi over 24. And then we have, if n equals 2, I would have 5 pi over 24 plus 2 pi over 2, which is going to just be, multiply that by 12, 24 pi over 24 pi. Okay, sorry guys, I doubted myself and was just double checking, making sure I was doing things right, and so far so good. All right, so then we've got 5 pi over 24 plus, this is going to give me 24 pi over 24, so that's going to be 29 pi over 24. If n equals 3, then I have 5 pi over 24 plus, that's going to end up being 3 pi over 2, or I'm just going to write it because I don't want to. All right, I need to make that match, so I'm multiplying both of those by 12. So 5 pi over 24 plus 36 pi over 24. 36 plus 5 is 41 pi over 24. I'm still not at 2 because 2 would have to be 48 pi over 24. But you can see the change here is by 12, and so 12 plus 41 is 53, and that would exceed that. I don't know why I'm going downhill. All right, now I need to address this one, okay? So I've got 7 pi over 6 plus 2n pi. Okay, so I'm going to multiply both sides by the 1/4 so that I can solve that for x. And this is going to give me x equals 7 pi over 24 plus 2n pi over 4. But I'm going to make my life a little bit easier, and I'm going to go ahead and multiply both the top and bottom by 6, so I have a common denominator right now. So then I have 7 pi over 24 plus 12 pi over 24. Okay, so now if n equals 1, then I would have 7 pi over 24 plus 12 pi over 24, and that would give me 19 pi over 24. That works. Okay, if n equals 2, then I would have 7 pi over 24 plus, this one would be 2 times the 12, so that's going to be 24 pi over 24, sorry. And that's going to give me 31 pi over 24. And then if n equals 3, then we have 7 pi over 24 plus 36 pi over 24, and that would give me 43 pi over 24. That's still less than that 48. And then again, we have a pattern of 7 going, sorry, not 7, 19 to 31, and then from 31 to 43. So we're going up 12. 12 and 43 would make that 55, so we're not going to work. All right, so I have this one, this one, this one, and the original one, right? The 7 pi over 24. And then I have the 5 pi over 24, where's the rest? Oh, 17 pi over 24, 29 pi over 24, and 41 pi over 24. So this one in itself has 1, 2, 3, 4, 5, 6, 7, 8 answers because it rotates on here 8 different times, giving us this value. That's insane, but that's how it is. So the answers for this one would be x equals 5 pi over 24, and I just realized you can't see my handiwork. Okay, so we've got 5 pi over 24. We would have the 7 pi over 24. We have 17 pi over 24. We have 19 pi over 24. We have 29 pi over 24. We have 31 pi over 24. 41 pi over 24, and 43 pi over 24. These would be the multiple angles that satisfy this equation, cosine 4x equals negative root 3 over 2. All right, like I said, that's going to be the one that you guys do not like, and I don't blame you because I'm not a fan of them either, but we have to do them because we can do hard things. Okay, let me know if you have questions. I'm sure you will.